All right, let's get started. Okay, we're going to get started again. So we're going to talk about what?
Do you like fresh juice? So I can ask him to prepare from tomorrow.
I like water.
But water is not enough.
It's fine. It's enough.
If you like strawberry juice or orange juice,
That's okay.
fresh, we can prepare it for you.
I'll have it, but I don't. It's okay. I'm okay without it.
Are you sure?
Yeah. Okay, so we're going to learn about watershed modeling with feature objects, and the thing that we're going to learn about is how to apply the rules of how feature objects are connected to create a drainage coverage. And we've kind of already talked about all this stuff. So far we've discussed some of these things like images, a little bit about getting data. Now we're going to talk about watershed modeling. So that's down here. And there are two ways of doing watershed models. One way is the just map-based modeling, and that's if you don't have a DEM. Or if you do have a DEM, then maybe you still want to manually define your watershed. That's map-based watershed delineation. The other way is DEM-based watershed delineation. And DEM-based watershed delineation is an automated way of doing map-based watershed delineation. But first we're going to talk about map-based watershed delineation. And watershed delineation is kind of the hard part, and then we'll talk about the easy stuff, and that's DEM based. DEM is just automated map based watershed delineation. So what we want to do, this is a watershed with 3 sub-basins. So I have 1, 2, 3 sub-basins, and I want to convert that watershed to use that watershed in a hydrologic model. And I have to do that, I have to have everything connected correctly, and everything has to be set up correctly to do that. So the place that you're going to set up your watershed model is in a drainage coverage. And a drainage coverage has polygons that represent your basin boundaries, arcs represent your streams, and points are used for your outlets. And you can manually define that basin boundary, or you can manually define your streams in a basin. When you do that, you have to create your streams from downstream to upstream. This is for watershed modeling. We're doing our streams from downstream to upstream, and that means if you start down here, and you go upstream. So here's a little stream that's on my topo map, my topographic map, and I want to draw that stream in. So you draw from downstream to upstream. What you don't want to do is you don't want to start at the upstream end. You don't want to start up here and then draw down here, because what happens if you do that, then WMS will create an outlet point at this location. WMS, when you create a stream, if the stream is not connected to any other streams, WMS will automatically create an outlet at the downstream end of that stream. So when I create a stream, it's going to create an outlet. If I start here and go from upstream to downstream, then WMS will create an outlet at the upstream end. That means my watershed model is defined assuming that outlet is at the upstream end of your watershed instead of the downstream end, which is not correct. So you always want to start downstream to upstream. Most downstream node always has to be an outlet in WMS. You cannot change that. It's always going to be an outlet. One of the rules that WMS uses is that WMS creates a separate outlet for each upstream branch. And so what that means is if I create an outlet here at this location, then WMS will create two subbasins because I have two streams coming out of that outlet. Does that make sense? So I have two streams. I have this outlet here defined where these two streams come together. WMS creates a basin, a subbasin for each stream that comes out of an outlet point. So I have this subbasin here that goes with this stream, and then this subbasin here, 5B, that goes with this stream. So it creates a basin for each outlet. So one way to get around that, if I don't want two subbasins at this location, I can go a little bit below that where those streams come together, and then WMS will only create one stream. Okay, is this making sense, or is everybody confused? Everybody's okay. All right. Another rule that WMS has, you have to have at least one stream segment in each of your subbasins. So here I have 3 subbasins, and each subbasin has a single stream inside of it. Here I have 2 subbasins, and each subbasin has at least one stream segment inside of it. You can have more than one stream segment inside of a subbasin, but you have to have at least one. You can't have 0. You have to have one or more. Okay, this is also fine. So any of those scenarios are fine. What I cannot have is I cannot have a basin like this with no streams inside of it. If I have that, then WMS will not, when it tries to create a hydrologic model, when you try to create a hydrologic model from this, WMS is going to, nothing's going to happen. There's no hydrologic model because I don't have any streams. What about this? What's wrong with this setup? Yeah, so this subbasin right here does not have a stream. So because of that, it won't have a watershed. There won't be a subbasin associated with this polygon here. Another thing is that the outlet point should usually be on the basin boundary. So, for example, for this set of polygons, I have an outlet point here and an outlet point here, and also it needs to be, the stream should be at the outlet point, and it will usually be at an outlet point, but the streams have to come together as well as the basin boundaries should come together at each outlet point. So if I zoom in to this location here, then you're going to see that no matter how close I zoom, that this outlet point is going to be attached to this basin boundary as well as this stream here. Same thing here, this location. If I zoom into that location, then I have these streams coming into this outlet point, this stream going out, and then I have these basin boundaries. And all of those have to be at exactly the same node. So what that means is if I move this node around, then all these lines that are attached to the node should be attached to the node, and they should move with the node. Everything has to be attached to the same location, the same node. When I import watershed data from ArcGIS or from CAD files, sometimes things might not be connected correctly. So this might look fine. This might look like I have 3 watersheds here and all my streams are in the right location and all that. But one problem I have is that maybe the streams are not in the correct direction. So maybe they're not going from, maybe the streams weren't created from downstream to upstream. And also maybe my outlet, my streams and outlet points, and my basin boundaries are not all connected together. So I need to fix those things. And so something like this is my basin boundary and my stream. I need to attach those all together. I need to get all my streams so they're in the right direction. That's if I import data from ArcGIS or from CAD data. Once you've done all that, once everything is connected correctly, WMS will be able to create this tree model of your watershed. This is called the topologic tree or the hydrologic tree. Topologic is just a tree that's connected by topology. So there are connections between your tree nodes. And we call it, in WMS, it's just called a hydrologic tree. And this, you can see this tree, if I go to back to here to WMS, so if I go, let me turn off these arrows, stream arrows, and we'll go to the drainage coverage. If I go to the hydrologic modeling module, you can see this tree, okay? And in this case, it looks like I have an extra outlet point here, and that's probably why I was getting that error message. So I have this outlet point, and you'll notice that this outlet has two arcs going upstream from that outlet. So because of that, WMS created a basin for each of those arcs. In fact, I probably need to redelineate my watershed. Let's redelineate my watershed. Oh, I guess that deleted one of my streams because I created one of the streams manually. But it kept that outlet point. So if I go to the hydrologic modeling module now, this is the hydrologic modeling module, you can see the tree, the hydrologic modeling tree. So this brown square represents my watershed. So these brown squares represent my watershed. I can tell they're connected to these polygons because when I select the brown squares, it also selects these polygons. And same thing with this watershed. These yellow circles, and it doesn't matter where these are. These can be anywhere. In fact, this tree used to be in a separate window. I don't know if you used WMS 15 years ago, then the tree actually used to be in a separate window from the graphics window. It had a separate window, but now it's all together, and it doesn't. But this is called the topologic tree, and it's just how the basins, the subbasins, and the outlet points, and the reaches and things in your watershed are all connected. WMS automatically creates this topologic tree, and you actually define your watershed model on the topologic tree. So if I want to do a HEC 1 model, I would go to this basin icon, and I can right click on it and go to edit parameters, and I can define all my hydrologic data for that watershed, for that subbasin. And then I do that for each of my subbasins, and my model will be set up. That's the topologic tree. And that's what WMS, if I have all my map data, my streams and outlet points and basin boundaries are all connected correctly, then WMS will automatically create this topologic tree. Now, we've been talking about map-based watershed modeling. So that's watershed modeling without worrying about any DEM data. It's not automatic. It's manual map-based watershed modeling. No elevations the advantages of map-based modeling are no elevations are needed, It's a nice representation of your watershed. You can compute your areas, but you cannot, and it's good if you have CAD data and GIS data. You can bring that in and convert that to the map module and do your map-based model. But you cannot compute elevation dependent parameters, so your slopes and some other parameters cannot be computed. Anything that's dependent on your DEM data cannot be computed if you do map-based delineation. And it also requires a lot of user intervention, and so it could be kind of frustrating trying to do map-based delineation, because like I say, everything has to be connected correctly. So let's do a map-based delineation. I'm gonna delete this. Actually, let's just delete this model. Okay, I don't know, let's just say I have some watershed that I'm going to model here. And it's kind of hard to tell where the watersheds are on this map, but let's say I have a topo map or something and I'm going to model the watershed manually from this map. Or maybe I have some data that I'm going to read in. Maybe I'll read in some data later and show you how I would manually read in that data and then convert that to a watershed model. So to do a watershed model, map-based watershed modeling, what do? What's the first step? Okay, yeah, so just create a stream. So I can select this. Yeah, so you can determine where the outlet is. And when I create a stream, one thing to remember is when I create a stream, at the very downstream end, that will always automatically be an outlet. So by defining my stream, I'm also defining my outlet location. So let's say, I don't know, let's say I'm going to do some watershed over here somewhere. And I don't know where they are, but let's just create my stream, okay? Something like this. So that's my stream. Okay, and right now that's not a stream. It's actually a generic arc, so I need to change the attribute of that. So I'm going to go to the attributes and change that to a stream.
Do I need to change it one by one, or after I finish all the stream network and I select all the arc and I select the stream?
So WMS, when you go to the feature objects and then attributes, any new arc I create now will be a stream arc. So if I have a branch or something, a stream branch in here, something like this, maybe that's another stream, then that will automatically be a stream. And so you can add any other stream in. Maybe I have another stream coming off like this that I want to define. Any arc that I create now will be a stream. So these are all streams. And I can make sure I created them in the right direction by turning on that stream arrows option. So go to the display option and turn on stream arrows, and you'll be able to see if all these streams are pointing in the right direction. Okay. So let's do another outlet point maybe. So I can go in. One easy way to do another outlet point is go to the drainage module, and you can click on this create outlet point tool and just create an outlet point that's on. Make sure it's on the stream somewhere. If it's standalone over here, then WMS will an outlet point has to be assigned to a stream for you to do a watershed model with it, and so you can't have just a standalone outlet point. So I'm just going to delete that. Anyway, so here's my watershed model. let's create an outlet point on the stream here, another outlet point. So there's my outlet point. Since I have a DEM, the DEM actually has flow accumulations, and so when I create an outlet, it's actually going to, WMS is going to snap to the nearest flow accumulation. Let me just delete this DEM for now. That way it won't, we won't worry about, we don't have any elevation data. Yeah, so if I use this, it should be at a node. An outlet point should always be at a node. And if I use this tool here, WMS, what it actually does is it creates a node on the arc. So it actually splits this arc. The way you split an arc is you create a node. And so I have a node here. And so if I select this, I can go to this attributes, and it's set to be a drainage outlet. You can also just manually create a drainage outlet. If I create a node, which is also use this create feature point and create a point along an arc, then I can create that point, and then I can just right click on this and change that to a drainage outlet. Okay, so then I have an outlet here. It's kind of hard to see, but so I have this outlet and this outlet. I'm going to get rid of this outlet. One way to get rid of the outlet is just convert that to a vertex. That'll delete the outlet. Yeah. Is it what?
Is it digitization?
Yeah, you're just digitizing the streams. Yeah. It creates a problem with your model. So you're saying if you select this and just hit delete to delete it, yeah, that could be a problem if you do that. Usually what you would want to do is you can convert that to a vertex, or you can go to the attributes and just change it so it's generic. And that's the correct way to delete an outlet. If you just select this point and delete it, then it's going to actually delete that point, which could, if you have watershed boundaries or something around that, then it could create some problems with your model. So the way I would delete an outlet is I would just change it to generic. We don't have a delete outlet tool necessarily. We just have we can change the outlet attributes, or just change it back to generic, or we can convert this node to a vertex, and that's going to delete all the attributes at that location. Okay, so let me just create my basin boundaries. So I'm just going to draw in some basin boundaries here. So let's say this is my basin boundary. And remember, my current attribute is set to stream arc. So it thinks I just drew a stream arc around everything. WMS thinks I did. So it says stream arc cannot close on itself, convert to generic. Yes. And so now that's a generic. And I think what I want to do is go here to the attributes, make sure this is set to generic, and it actually changes that if the if it converts something to generic. Now, okay, so what am I missing here? Create the top basin. Okay, so I need to draw in my basin boundaries for my top basin. Let's just say, I don't know, let's say it's something like this. So those are my basin boundaries. Okay, what else? Okay, so
Create polygon first and then convert the polygon.
do the polygon, build the polygons. So I'm going to right click on here, build polygons, and then what? Okay, I already have the drainage boundaries. I manually defined the basin boundaries here, right? I've manually defined them. Yeah, these are the basin boundaries. This is map-based delineation, so I'm manually defining some basin boundaries. Yep, it does. Well, I can make sure, so I can go here and make sure that's a drainage boundary. So go to the select polygon tool, make sure that one's a drainage boundary, and they are.
So can we calculate the characteristic?
Yeah, so just compute the basin data, right? So I'll go to feature objects, compute basin data, and hit OK. So those are my basin areas. Yeah, right. So we'll be able to compute. If we go to drainage data, we can compute things that don't depend on the slope, like maybe basin lengths, and maybe they don't depend on elevations. I don't know what else. Stream length, so maximum stream length, shape factor. Okay, let's look at those. So that it's able to compute those things. It's not able to compute things that depend on slope, like max flow slope, mean basin elevation. Those are going to be 0. So here you have.
If I want to run a hydrologic model, so I need to introduce the bench concentration.
Uh-huh.
And it depends on the slope. So can I define the value for the slope, or I have to?
Yeah. So you could manually go in here. So now if I go to the once I've computed my basin data, I can move these. There's this tool that allows you to move this move basin label tool. Allows you to move the computed data off to the side so you can view stuff. But if I go to the hydrologic modeling module, so you can see that WMS has this. This is one of my basins. This is the other basin, and this is the outlet point right here, and this is the other outlet point. And so this is my tree. The other thing that I should mention about this tree is it's displayed over here kind of as under the drainage. This is the drainage coverage tree, right? And your question was, how do I edit the slope and other parameters if I haven't been able to compute it? Well, you can go over here to the properties window, and you can go basin slope. BS stands for basin slope, and let's say it's 0.01. You can go in and enter that in there. The other thing you could do is, if I go to the parameters, and then there's different places where you can edit these parameters. But if I go to the unit hydrograph and then basin geometrical attributes, and these are all the basin geometrical attributes that are computed. Some of these values are 0. You can go in and edit these values from this window here. And these are the values that are used to compute your time concentration or your lag time for your watershed. Okay, so that's map-based watershed delineation. Really the important thing about map-based watershed delineation is that you get all of your things connected correctly. Your streams and your basin boundaries all have to be connected at the same location. Like for example, one thing that you might do is when you draw in your basin boundary, let me just show you something here. So if I were to draw in this basin boundary, let's click right here, and then we're going to draw in a basin boundary up to here, let's say. And then I'll just build my polygons. The thing that happens is, a thing that could happen is this polygon or this arc is not connected to this outlet point. Okay, so WMS creates this small arc right here, and so you end up with something like this, and your delineation is not correct. When I build my polygons, if I try to select this polygon, it just selects the whole thing because WMS doesn't think there's a polygon here because I have streams that my basin boundaries do not connect at the outlet point. So I can fix that, or I could just redraw the basin boundary. The way I'd fix this is I just delete this stream here. So select that, hit delete, and then just snap these two nodes together. Select those, right click, clean, snap selected nodes, hit OK. It says select a snapping point down here at the bottom of the screen, so I'm going to select this point. And then I can rebuild my polygons, and then I can recompute my basin data, and everything's set up correctly. So you always want to go to you want to make sure if you go to the hydrologic modeling module, select this basin, make sure that selects the polygon for this basin. This is if you're doing map-based watershed delineation. After lunch, we're going to talk about DEM-based watershed delineation. For DEM-based, it's all automatic. It creates the same kind of map, but it does it automatically. And that's kind of what I've been showing you all morning until I showed you this, until we worked on map-based. We've done DEM-based, and it's an automated way of doing map-based watershed delineation.
If I have the stream network,
Uh-huh.
I create and using ArcGIS, and I want to go to using as a I open the shape file for the boundary, and I open the shape file for the how can I define the outlet?
Let me show you that. So you're wondering if you have a shapefile for your basin boundary and a shapefile for your stream, how do I create a model out of that? Well, I have, so on the disk here we have we have some shape files. Oh, I got the wrong one. Just a second. Alright, finally got it. So here I have a shapefile of streams. And basin boundaries. And let's say I want to convert this to the map module. And these are all just arcs right now. So I'm going to select, so the way you do that is you select this, go to mapping, shapes to feature objects, next. And then WMS has an arc type, drainage arc type. I don't know that I'm going to get into this, but anyway, I can just convert this to the map module. And these are my streams. My streams are all going in the right direction. And I just need to define my outlet points. One thing you need to make sure of is that you need to make sure that your streams are connected to your basin boundary. So when I move this node around, then that's connected to the basin boundary. Okay. WMS is automatically going to create an outlet point at the most downstream location. So that's taken care of. But then I just need to create outlets. I need to make sure that these streams and the basin boundaries are connected. They may not be. If they aren't, then I could just use the clean command. I can just right click and select clean, snap those nodes to some other node. Then I just define my outlets. Okay, so I'll define an outlet there. And then I have some other places where I have a watershed boundary. I'll just define outlets at those locations. So here, here, define those as outlets. And I have another outlet right here. So right at this location. Set that to be an outlet. And then I just build my polygons. So right click on the drainage coverage, build polygons. And just make sure, like you said, make sure that these are set to drainage boundary polygons. And then make sure go to the hydrologic modeling module, make sure my topologic tree is set up correctly. So make sure each of these basins has a polygon associated with them. Okay, so that's how to read data from a GIS and use it in WMS. Are there any other questions about this? About this is map-based delineation. So after lunch, I think we're going to talk about DEM-based delineation, and then we'll talk about watershed modeling, and we'll start setting up some HMS. You guys want to learn about HMS or HEC 1 or both of them? We can kind of talk about both of them, HMS and HEC 1. And we'll start talking about that after lunch. So, no other questions? I guess we're all done then. Let's break for lunch.